Okay, one of the review problems here that I didn't get a chance to go over with you guys in class is to factor a polynomial like this when you're given a factor. Well, being that I know that x minus 3 is a factor, I'm going to take advantage of this and I'm going to use synthetic division to divide 3 into this function. So I have 3x cubed, I have 11x squared, I have negative 67x, and I have the positive 21 constant. So our synthetic division, we should get a remainder of 0 here. This makes 20 when I add. 3 times 20 would give me 60. Add that, I get negative 7. Multiply, negative 21. Add, we get 0. So that's good. We have a remainder of 0, which is what we had expected. Then this is the constant, the x squared. So this is 3x squared plus 20x minus 7. Now what I can try to do here, if I want to, I could actually graph this function. That's not a bad idea. So I can go into my y equals and type in 3x squared plus 20x minus 7. It does factor. You can factor it, but I'll show this way because I know a lot of you are struggling with the factoring a little bit, but you do need to practice that. So here it looks like we're crossing at, if you count, 1, 2, 3, 4, 5, 6, 7. This is at negative 7, so I'm going to say that we should be able to divide by 7. I'm sorry, negative 7. So let's do that. We'll take negative 7 and we'll divide it into 3x squared plus 20x minus 7. Hopefully we get a 0 remainder here. Bring down our 3, add, multiply, add. It works. Good. So that's our constant. This is our x. So this becomes 3x minus 1. So I get 3x minus 1 is a factor. I have this guy here, that's going to be x plus 7. And this guy here is going to be x minus 3. So that's the factored version. If you were to take these three things and multiply them back together, it should bring you right back to what we started with. So that's a first problem. A second problem, here using the remainder theorem, we're going to take and evaluate the function negative 7x to the fourth plus 3x squared plus 2x minus 1 at the value of x minus 0 using the remainder theorem. Well, one way to get this answer is to just take negative 1 and plug it in for x and see what you get. So I encourage you to do that, and what we're going to do here is demonstrate this using the remainder theorem. Basically what that says is I can divide by the negative 1 into negative 7x to the fourth plus 0x to the third, and then we have 3x squared plus 2x minus 1. The remainder, when we're done with this, is going to be the same as our function value. So I can show you that real quick. Taking from the main screen here, I can just take negative 7 times, we're going to do x is negative 1, and that's going to be raised to the fourth power, plus 3 times the x value, which is still negative 1, squared, plus 2x minus 1. That should be what we get as the remainder when we're done with our division here. So let's see if that works. It should. So I bring down my negative 7 and I multiply and add. I multiply and I add. I multiply and add. I multiply and I add. Something went wrong here. What did I do wrong? 0, 7, positive 7. Ah, here it is. Sorry about that. Let's back up. Sorry guys, I just discovered my mistake here. It was in the calculator. when I was plugging in -1, I accidentally didn't put it in here. So this should say 2 times -1. So let me put that in here. 2 times -1 and then -1. Sorry about that. A little bit too much of a hurry. So we should get a remainder of -7. That's what we should get here. So anyways, and that looks good. If I do this, finish this off, -1 times 6 is -6, and sure enough, we get what we're supposed to, a -7. So the remainder theorem says that this is the function value at x equals -1. If we were figuring out the function value at x equals +5, then this would be a 5 in the box. I would divide, and my remainder would be the same thing as I get when I plug in 5. So that's the remainder theorem as a second problem here. Here's another one. We did these in class, but I wanted to take an opportunity to do another one of these with you. We're looking for a polynomial that has zeros, or roots, I'm sorry, of 4 and 3 plus I. And so what we saw that means is that x minus 4 is going to be a factor, as well as x minus 3 plus I, put it in parentheses. And don't forget that these complex ones occur in pairs, so we are also going to have x minus 3 minus I. So I multiply this out, x minus 4, and now I'm going to regroup here. This is going to say x minus 3 minus I on the first one, and the second one is going to say x minus 3 plus I. So when I multiply out, x minus 4 is going to get multiplied times x minus 3 squared minus I squared, which becomes x squared minus 6x plus 9 is what I get when I square x minus 3, and then this becomes plus 1. So I have x minus 4 times x squared minus 6x plus 10, and now I just need to multiply this out and I will have my polynomial. So x cubed minus 6x squared plus 10x, and now distribute the minus 4 plus 24x, and then minus 40, and combine like terms. We get x cubed, pen is slowing down on me here, minus 10x squared and then 24x plus 10x is 34x, and we have the minus 40. And there we have that one.